grade 11s, welcome to another video. I'm sorry that I'm sending it out so late. I was extremely busy this afternoon, but I really want to help you by just putting the three proofs that you need to know into a video. So this is not all the proofs that you need to know with Euclidean geometry, but just the first three. So I'm just going to run through the first three because that is what my students are writing about, and they should be able to prove this. Okay, so let's have a look at Theorem 1a. The line from center is perpendicular to chord. So they would give you this diagram and they will say, given that OM is perpendicular to AB. All right, so they'll give you that. And then they ask you that prove that AM is equal to MB. Sorry, I've got some notes left from the previous video. All right, so prove that AM is equal to MB. So I always, with all my proofs, I just have a few notes to remember. So notes to remember is, firstly, we're going to join OA and OB. And then we're going to prove this, that AM is equal to MB with congruency. All right. So whenever you add to your drawing, please, you need to remember to go and state that you've done that. That is your first mark that is allocated to your proof. So with that, I'm going to say that I'm joining OA and OB. All right, so with that, I know that I'm creating, or what I did is, because that is, O is the center of the circle, I know that I've used two radii to join them. Okay, so the next dot says proof using congruency. So in congruency, we always start with saying, in triangle OAM and triangle OMB, doesn't have to be in order for now. I want to prove that they are congruent. So I need to list three things. If you can remember congruency, and then you're going to say thus triangle, and now I'm going to try and keep my order correct. So I'll have to keep my order correct. So I'm going to start in the center. OMA. MA is congruent to triangle OM, so OMB. And we know that we'll have to use right angle hypotenuse side. Okay, so the first thing is first, my radii that I joined there. So OA is equal to OB because of radii. Then this that's given to me, given that OM is perpendicular, so I'm going to state that angle M1 is equal to angle M2 is equal to 90 degrees because it was given. Okay, please don't forget your little cuppy on top of your the letter that you are using, because you have to indicate that it's an angle. If you don't, you might lose a mark for notation. Okay, so please make sure to remember that. And then the very last one, remember the common side. OM of the one triangle is equal to OM of the other triangle. So OM is equal to OM because of the common side. Okay, so thus they are congruent. So with that, you can conclude then, because they are congruent, can you see then that AM is equal to MB? And the way it is in order here as well, AM or MA is equal to, MB over here. So MA is equal to MB. Okay, because they are congruent. And that is the proof of Theorem 1. Okay, let's look at Theorem 2. They will ask you, prove that the angle at center, or use the diagram below to prove that the angle at center is equal to 2 times the angle at the circumference. Okay, so very important, this red line over here, I've added in. So they would not give you this red line over there. You are going to add it in, and we're going to say, let me just add it over there. You're going to say join CO and produce. Okay, so it means and extend. So you can also say join OC as to be extended, and the same in this diagram over here, and the same in diagram 3 if it was given like that. Okay, most of the time we like to give you this original. All right, the first or the second. Okay, so join CO and produce. Then we're going to start with that O1. Sorry, and I've made some notes over here. So remember, exterior angles of a triangle, radii, angles opposite equal sides. So these are the 3 reasons, external reasons, that we're going to use to prove this theorem. Okay, so the first thing for exterior angles, so you can even remember it like that. Exterior angles of a triangle is the radii, is the angles opposite equal sides. Exterior angles of a triangle is the radii, is the angles opposite equal sides. So exterior is rad, angles opposite equal sides, or something like that. I always like to add a little bit of a rhyme or a joke. Okay, so that is your first mark. So if you ever don't remember anything, just say join CO and produce. Okay, so don't forget about and extend, because it has to be extended for you to use this. All right, so now with your exterior angles, can you see that this over there and this over there creates that exterior angle over there? So we're going to say that O1 is equal to C1 plus angle A because of exterior angles of a triangle. Okay, and now your next thing to remember is radii. So exterior radii, angles opposite equal sides. Okay, so now for the next thing, we're going to say that OA is equal to OC because they are radii. And then lastly, A1, which makes A1 equal to C1 because of angles opposite equal sides. Oopsie, sorry. Angles opposite equal sides. Okay, so join. You're going to get a mark for over here. And this one sort of goes hand in hand. You first have to say they're radii, so that's angles opposite equal sides. Okay, so then we're going to say, okay, so now because they are equal, you can say that O1 is equal to 2 C1s, because you've got this one over here, this exterior angle is equal to this one plus this one. But because I proved that they are equal, then it's like saying that O1 is equal to twice C1. Okay, and then you're going to do exactly the same on the other side, so you don't have to write it out. You can just say, similarly, in triangle, try to be as descriptive as you can. Triangle OBC, O2 is also going to be, can you see that O2 is also going to be 2C2s. All right, and then with that, you can conclude then that O1 plus O2 is equal to 2C1s plus 2C2s, which will make it that, if you had to factorize that and take out a 2, that O1 plus O2 is 2 times the angle of C. So thus, angle AOB is equal to 2 times angle ACB. And there you have it. All right. So please make sure that you've got everything that's very important. You've got join. Sorry, let's put a little dot there for join. CO and produce. Okay, or join CO and extend. Another word you could have used is extend. So then you've got for exterior angles, for these two you get, and then for saying O1 is equal to 2 times C1, then similarly then doing the equation, and then coming to your conclusion. All right, so this will be easily roughly out of 1, 2, 3, 4, 5, 6, 7 marks. Okay, and people, if needs be, you write this out over and over and over until you've got everything that's needed. Okay, all right. Then the last theorem, not that we need to know, but just for now, where my grade 11s are, they're writing about all these three that they have to prove. So theorem 5 is notes that you need to remember. You need to draw OA and OC and use the reasons angles at center equals 2 times the angle at the circumference. So we're going to use one of our theorems to prove this theorem as well. Okay, so first things first, if you get given this cyclic quad, it says to you, given that ABCD is a cyclic quad, and we're going to, in the cyclic quad, we're going to join AO and OC. Okay, you need to write that. That is very important. Okay, so we're going to join AO and OC. Oh, looks terrible, but there we have it. Okay, then we're going to say, we're going to label this O1, O2, and then we're going to say that O1 is equal to 2 angle D. Why? Because of, and I don't have 2 points, but it's angle at center equals twice the angle at the circumference. So can you see your little triangle, or your little, what would you call it there? Your little bow arrow. Okay, so O1 is equal to 2 angle D, because of angle at center equals 2 times the angle at the circumference. And similarly the other way around, O2, remember, is twice angle B. Those two bows have to face the right way. So please, people, please make sure that you don't is equal to 2 angle B. Please make sure that you don't forget your cuppies, okay? Because you have to say that it's an angle. You're going to get marks deducted if you don't have that for notation. Okay, and again, this will be angle at center equals 2 times the angle at the circumference. And so now we're going to sort of use our algebra, and we're going to add those two. So O1 plus O2 is equal to 2 angle D plus 2 angle B. All right, I explained it in class, so just if you are interested, so if you've got 5 is equal to x plus 3, and I don't even know if I must, let me not use variables, is equal to 3 plus 2, as well as 6 is equal to 5 plus 8. Can you see if you add those together, it will add up to the other side as well, and that is the algebra that I'm applying over here. Okay, so now we've got that, but we know that O1 and O2 is equal to 360 degrees. Okay, so that's the previous step was done with algebra. So now we note that O1 plus O2 is equal to 360 degrees because angles round a point. Okay, so now we can go and replace that into the value there. 360 is equal to 2 angle D plus 2 angle B. And then if you bring them together, if you if you simplify, you divide by 2 all throughout, you get 180 is equal to angle D plus angle B, which will prove this that they've asked. Given ABC is a cyclic quad, and they say prove that the opposite angles of a cyclic quad are equal to 180. Okay, so you can always do this, and then at the end you must just go and add and say, well, similarly, by joining, oh, let me just write it nicer, sorry, by joining DO and OB, it can be proven that angle A plus angle C is equal to 180 degrees. Okay, so you can always go, but it depends on what they ask you. If they say to you, the opposite angles of a cyclic quad is equal to 180, you could have used any pairs to use. If they specifically told you prove that angle A is equal to angle D, then I would have rather joined these two lines and then used those to work with the opposite sides of a quad are equal to 180. All right, I hope that makes sense. That was quick, sorry, and in a nutshell, because I worked so late and the kids, I had to look after them and get them ready for tomorrow, etc. So there they are, the 3 proofs that you need to know up to now for grade 11. I hope that helps. Hope you have a great evening, grade 11s. Cheers, bye.